Hi everyone. So today we're going to discuss the last mission, mission 3 from Unit 1C. And the last mission is about reading and writing numbers using scientific notation. So when we discuss topic like that of writing numbers in scientific notation, always think about some really large numbers and some really small numbers. That's the whole idea. And the purpose of using scientific notation is because sometimes all those really large numbers will have so many digits that we maybe can't write them, that because it's going to be so long. That's why we need scientific notation form, so we can write it down and space it and having all the numbers seen. Same thing with really small numbers. Imagine something, for example, pi, how many digits do you have after the decimal point? We can't write them. Some numbers, they go forever. But if we have a method of using to simplify this and have only maybe two digits, that will be great. So the idea of scientific notation is to use this method in order to simplify and make the numbers look very in good form that we can use and deal with. So it is a way to write very large or very small numbers. Go ahead and write this down. So that's what the scientific notation is used for, to write very large or very small numbers. Once you have written down the reason for using scientific notation, next thing I want you to write this big number on your paper. So we have 6, 320, 3 zeros, and another 3 zeros, and on the end is my decimal point. So we have thousand, millions, billions, trillions. Really big number here. Okay? So now, how do we write this number in scientific notation? In order to write the number in scientific notation, we need to move the decimal point as many times we need until we reach the positions between the first and second number. Okay, so here's what we do. You grab the pencil and you start counting 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 jumps to the left. We move the decimal point all the way from the end to the beginning of the number, but we always move it between the first and second digit. So what that means is I'm gonna copy the numbers here. So I will put 6, I will put the new position of the decimal point, and then I'm gonna copy those numbers, 3 and 2, different than 0. And we'll say this is equal to 6.32 times base 10. So when we talk about scientific notation, we use base 10 to the power of, because there are 9 jumps, then to the power of 9. And that will be the form I need to write this big number. So this is what we call standard form. This is what we call scientific notation form. From standard form, we convert the number in scientific notation form that is easy to write and calculate if we need to. What happened? So basically we're moving the decimal point to the left in order to get a smaller number with scientific notation form. That is when we have big numbers. What happened when we have a small numbers? Now look at this number. We have 0.000027. In this case, the decimal point is right here. So again, our goal is to move the decimal point as many times we need to until we reach the first number and the second number of the line. Once we reach it, we also count the jumps. So we have 1, 2, 3, 4, 5 jumps here. So my new look of the number in scientific notation will be 2.7. The decimal point is right here now between 2 and 7 times 10, and to the power of 5 because we just made 5 jumps. And again, from a small number in standard form, I just wrote this in scientific notation form. Alright, so this is the general rule and information. Next thing, we're gonna go ahead and do some practice together. So following those steps and the rules, go ahead and write down some numbers from the first example. So go ahead and write the numbers in scientific notation, and we have 4 numbers given: 59,140,000, 0.3046, 0.409. So if you have the first number written down, and it's a big number, we all know that the decimal point is on the end of the number. We don't see it, but we know it's on the end. So let's move this decimal point now all the way to the beginning between the first 2 numbers, and we're gonna count how many jumps we need to make in order to get to this point. So let's count: 1, 2, 3, 4, 5, 6, 7. 7 jumps. I will just put down here 7, that will remind me. Okay, so I'm gonna copy 5.9 times base of 10 again, and to the 7th power because of the 7 jumps. And that's it. We're done with this example. So we're gonna do another one. 140,000. Again, the decimal point is on the end, and we want to move this point between the first 2 numbers. So we're gonna start counting or jumping and moving the decimal point. So 1, 2, 3, 4, 5. 5 jumps here. So the answer in scientific notation will be 1.4 times 10 to the 5th power. Okay, very good. Now we're going to focus on small numbers. And by the way, I need to add one thing to the small numbers, and I'm going to show you. I saved it so you can see it later and distinguish what's the difference between big and small number, because if we do exactly the same steps, you will say, then what's the point of doing those examples if there is no difference? We do exactly the same thing no matter how big the number is and how small the number is. So I want you to go back here when we wrote the 5 jumps, and we had a very small number, and we rewrite this in scientific notation. So now I want you to write down a negative sign up here. And remember, every time we deal with large numbers, we keep the exponent positive. Every time we deal with really small numbers, then the exponent becomes negative. So let's take a look at those small numbers. We have a decimal point right here, and our goal is to move the decimal point between the first 2 numbers on the row, and those 2 in this case are 4 and 6. Okay, so now we're gonna count the jumps. We have 1, 2, 3, 4 jumps here. So my number will be 4.6 times 10 to 4 jumps with negative exponent, because it's a really small number, and when we have those small numbers, we always write negative exponent. Okay, and the last example, we have 0.00009. Your goal is this decimal point to move it here, to pass the first number. We may not have the second number, but we have to pass the first one. Okay, and count the jumps. 1, 2, 3, 4, 5. 5 jumps. So it will be 9, and you can say 9.0 or just 9 times 10. 1, 2, 3, 4, 5 jumps here. It will be to negative 5 exponent. So again, look at this. Big numbers, positive exponent. Small numbers below 1, 0.99, 0.9, 0.0005. All of those are considered small numbers. They all have a negative exponent. Okay, so following those rules, now we're going to take a look of how to write from scientific notation back to a standard form. So look at the example below. Now we have given the scientific notation form, and we're going to go back to the standard backwards. So I have 0.56. And it's given to be a negative exponent. Since I have negative exponent, this shows me I need to have a very small number, which means I have to move this decimal point all the way to go to the left. Because if I move it to the left, I'm going to add zeros here and will make the number small. Okay, so we need to move 3 steps. 1, 2, and 3. Okay, so when you move 3 steps, we have 2 empty spots here that we're going to fill out with zeros. So my standard form now will be 0.00356. That's the answer. And of course, in front of the point, the decimal point, you have 0. With the next example, we have 5 jumps, negative 5 jumps. So again, we gotta go to the left 5 times. So we make 1, 2, 3, 4, 5 jumps. When you make those 5 jumps, you gotta fill out this with zeros. And we have, this is equal to 0 point. And now I have 4 zeros, 1, 2, 3, 4 zeros, 2 and 4 numbers. Next 2 examples, we have a positive exponent. In this case, because it's a positive exponent, so this point needs to go to the right, okay? And the reason we're moving to the right, because when I move the decimal point to the right, I will get large number. From 1.36, the number will change to maybe 10,000 or 1,000, and it depends how many jumps we need to do. So let's do 3 jumps here. 1, 2, 3 jumps. And I will start writing 1, 3, 6, 1, 0, and then is my decimal point, and we can end with 0. So 1.36 times 10 to the third is 1,360. And if you want to go backward and count 3 jumps, you will see that we will get exactly the same number. Last example here is when we have 2.461 times 10 to the 7th. So 10 to the 7th shows us that this decimal point needs to move to the right 7 times. So we have 1, 2, 3, 4, 5, 6, 7. And because this is a little bit small, I'm going to write a small zeros here. But this is what we need to get as a standard form answer. So we will have 2, 4, 6, 1, and then we have 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. And if you want to put comma to divide the number, to see how many thousands or millions we have, this is what we get. 2.461 times 10 to the 7th is 24,610,000 in a standard form note. So I'm gonna stop here, and I'm gonna make another short second part video of this lesson that will emphasize on little bit of comparison between the numbers. So the first video is, the main focus is how to write those numbers from standard to scientific notation and from scientific to standard form. Next video will show you how to compare numbers, which one is larger and which one is bigger. Thank you for watching the video, and once you finish with this one, please make sure you watch the second part as well. Have a great day, everybody.